Yeah, hello students, greetings of the day. This is your Eknath sir, faculty in physics from VIP classes. Yeah, today we'll talk about ammeter and voltmeter and their construction and how do we connect this ammeter and voltmeter, okay, in the circuit. Basically, we're using galvanometer for detecting the presence of current in circuit, right? So, हमें galvanometer किस लिए यूज़ कर रहे हैं सर्किट में? Okay, to detect the presence of current in a circuit, we are using what? गॉल्वोमीटर को हम यूज़ कर रहे हैं. तो फिर वही गॉल्वोमीटर को हम कैसे मॉडिफाई करेंगे? ओके, वो वोल्ट मीटर जैसे यूज़ करने के लिए और अमीटर जैसे यूज़ करने के लिए. तो गॉल्वोमीटर को क्या करेंगे बोलते हम? सो द गॉल्वोमीटर को कुछ रेजिस्टेंस रहेगा जी. So this galvanometer can be converted into ammeter. So if we connect a small resistance in parallel, that is called shunt resistance बोलेंगे हम. Okay, so मान लीजिए it has to measure the circuit current I and galvanometer shows full scale deflection for मान लीजिए IG current के लिए, and remaining current passing through this one will be I minus IG, and again I minus IG will come this side, IG will come this side, and this will go as I current in the circuit. So here why we have to modify the galvanometer is the concern. Okay, here see galvanometer has some finite resistance 50 ohms 100 ohms and all. If you connect directly galvanometer in series, no, effective series resistance of circuit what happens? Increases. So जब हम डायरेक्टली सीरीज में कनेक्ट किए तो क्या हो जाएगा? उसका रेजिस्टेंस बढ़ जाएगा. जब रेजिस्टेंस बढ़ जाएगा सो सर्किट रेजिस्टेंस बढ़ जाएगा तो करंट सर्किट क्या होगा? I इज इक्वल टू अप्लाइड पोटेंशियल बाय रेजिस्टेंस, है ना. सो अप्लाइड पोटेंशियल तो कांस्टेंट है, सो रेजिस्टेंस बढ़ गया तो करंट घट जाएगा. दैट मीन्स व्हाट? इट इज इफेक्ट इन द सर्किट करंट. सो हम जो अमीटर को यूज़ कर रहे हैं, ओके, अगर उसको हम सीरीज में कनेक्ट किए तो डायरेक्टली जैसा गॉल्वोमीटर को डायरेक्टली कनेक्ट किए तो उस सर्किट के करंट को इफेक्ट कर रहा है. सो सर्किट करंट को इफेक्ट नहीं करना चाहिए वो. सो इट हैज़ टू मेजर एज इट इज द सर्किट करंट, ओके, विदाउट इन्फ्लुएंसिंग इट. ओके, सो बिकॉज ऑफ विच व्हाट वी डू, वी रिड्यूस द गॉल्वोमीटर रेजिस्टेंस, ओके, बाय कनेक्टिंग इन पैरेलल. हमें पता है अगर किसी रेजिस्टेंस को एक पैरेलल में रेजिस्टेंस कनेक्ट किए तो उसका रेजिस्टेंस क्या होगा? घट जाएगा. मान लीजिए एक 2 ओम है, इसको पैरेलल में 2 ओम कनेक्ट किए मान लीजिए, तो क्या होगा? पैरेलल में 2 इंटू 2 बाई 2 प्लस 2 4 हो जाता है ना, 1 ओम हो जा रहा है. सो व्हेन यू कनेक्ट 2 ohm resistance to another 2 ohm resistance in parallel, resultant becoming half, we know, isn't it? So smaller से भी smaller हो जा रहा है. सो 2 में स्मॉलर से 2 ही है तो उसमें से कम हो जा रहा है. इसका मतलब अगर पैरेलल में किसी एक रेसिस्टर को और एक रेसिस्टेंस कनेक्ट किए तो उसका रेसिस्टेंस क्या हो जाएगा? उसका रेसिस्टेंस घट जाएगा, इजंट इट? तो उसका रेजिस्टेंस हम क्या बोल रहे हैं? सो हम बोल रहे हैं कि गॉल्वोमीटर को अमीटर में कन्वर्ट करने के लिए सो वी आर कनेक्टिंग ए स्मॉल रेसिस्टेंस, किसमें? पैरेलल में कनेक्ट कर रहे हैं. इसलिए क्या हो रहा है? इफेक्टिव रेसिस्टेंस कम हो जा रहा है, इसलिए सर्किट करंट को उतना इफेक्ट नहीं कर पाएगा. फिर भी थोड़ा इफेक्ट रहेगा बट नेग्लिजिबल इफेक्ट रहेगा. तो इसीलिए अगर हम कितना वैल्यू ऑफ शंट रेसिस्टेंस कनेक्ट करना है, सो इसलिए हम क्या कर रहे हैं? गॉल्वोमीटर को अमीटर में कन्वर्ट करने के लिए इस गॉल्वोमीटर को, यहाँ सर्किट में देखिए, इस गॉल्वोमीटर को हम क्या कर रहे हैं? पैरेलल में एक शंट रेसिस्टेंस को हम कनेक्ट कर रहे हैं. सो इसीलिए नाउ, so when you are connecting a galvanometer in parallel, a small resistance like this, okay, shunt current value is I, current in galvanometer for full scale deflection is here Ig, and remaining current क्या होगा? I minus Ig होगा, है ना. तो यहाँ से करंट Ig आ रहा है, यहाँ से करंट I minus Ig है, दोनों मिलके यहाँ I बोल के जाएंगे. So for measuring, you can see current divider circuit acting like now here. So you can write all these two are in parallel. So potential difference same रहेगा ये दो पॉइंट्स के बीच में, है ना. So potential difference across galvanometer is Ig into G. Potential difference across shunt will be I minus Ig into S. So कितना shunt करंट करना पड़ेगा आपको? S is equal to Ig into G by I minus Ig. Okay, this is the value of shunt resistance which you have to connect, okay, in parallel. So for converting this galvanometer into what? Ammeter. Okay, this is the what value of shunt resistance we have actually done, and ammeter looks like this, but this actually contains what inside? So we have a galvanometer and what? A shunt resistance in parallel and put together. So this device looks like this device. Okay, this is called ammeter. Now we can check here. Now a resultant resistance value will definitely decrease than the what? Galvanometer resistance, and smaller than the smallest shunt resistance जितना भी कनेक्ट करेगा उससे भी स्मॉल हो जाएगा, because of which it won't affect the circuit resistance and you can able to measure the approximate the value of the current. Okay, Now, say a galvanometer with just one problem we'll understand here. So, galvanometer resistance of 100 ohm for full scale deflection of 1 milliampere. So, current through the galvanometer how much now? 1 milliampere. What shunt resistance you have to use so that it will convert a ammeter which measures a range from 0 to 5 ampere. So, shunt resistance which you have to connect formula is what? Ig into G by I minus Ig. Ig's value is how much here? 1 milliampere. So Ig is 1 milliampere into G is 100 ohms galvanometer resistance divided by I minus Ig. So I is 5 ampere maximum range minus Ig is 1 milliampere. Subtract approximately 5 or 4.99. When you divide it, no, you are getting nearly the resistance. Resultant resistance is this one. Okay, resistance which you are getting is actually this much. Okay, and the value of shunt which you are connecting, how much? If you simplify, 0.02, very very small, you can see. Okay, so like that we convert a galvanometer into what? Ammeter. Okay, so now you can practice this question. So a galvanometer with coil resistance 12 ohm shows full scale deflection for current of 3 milliamperes. Okay, so Ig का value दिया है आपको. Okay, Ig is equal to 3 milliampere, and for measuring a current of how much range? 0 to 300 milliampere. So maximum range how much? 300 milliampere. 10 power minus 3 ampere. So what value of shunt we have to use? Right? Use the formula. क्या होगा? Ig into G by I minus I. जिसको simplify करो, you will get the value of 0.0121 ohm. Okay. And what is saying? Fraction of total current passing through the galvanometer at full scale deflection. Fraction of total current pass through galvanometer. So Ig current through galvanometer by total current करो. That will be 1% here. Okay. Yeah. So now this is how we'll perform what? So a galvanometer converted into what? Ammeter by connecting a small resistance in parallel and which you are calling as shunt resistance. Okay, right. Now let us convert this galvanometer into voltmeter now. So voltmeter is a device which is used to measure what? Potential difference between any 2 points in the circuit. अगर किसी दो पॉइंट्स के बीच में पोटेंशियल डिफरेंस निकालना है हमें, तो हम क्या करेंगे? इस वोल्टमीटर को कनेक्ट करेंगे. सो पैरेलल में कनेक्ट करेंगे. कैसा? पैरेलल में. क्यों पैरेलल में? इट शुड नॉट अफेक्ट द सर्क्यूट करंट. Okay, and moreover in parallel combination we have seen that potential difference remains the same. So इसलिए now galvanometer if you directly connect, no, what happens now? So what happens here now? You are connecting a large resistance in series connect कर रहे हैं. Okay, इसको क्या करने के लिए? वोल्टमीटर में कन्वर्ट करने के लिए. So मान लीजिए ये पॉइंट A है, ये पॉइंट B है. जब हम करंट सेंड कर रहे हैं I, ओके, सो इसमें से कितना जा रहा है करंट? Ig करंट जा रहा है. सो फुल स्केल डिफ्लेक्शन ये शो कर रहा है. तो अगर हम सर्किट में इक्वेशन ले तो VA यहाँ पोटेंशियल ड्रॉप कितना होगा? माइनस Ig इंटू जी. यहाँ पोटेंशियल ड्रॉप कितना होगा? माइनस Ig इंटू आर. दैट मस्ट बी इक्वल टू पोटेंशियल एट बी. सो इसमें से क्या निकल सकते बोलो? VA माइनस VB क्या हो जाएगा बेटा? सो Ig इंटू जी प्लस आर हो जाएगा. सो ये होगा रेंज ऑफ पोटेंशियल विच हाउ टू मेजर, विच इज इक्वल टू Ig इंटू जी प्लस आर. ऐसा लिख सकते हैं. या कितना रेसिस्टेंस चाहिए ऐसा भी कर सकते हैं आप. V माइनस Ig इंटू जी. ओके, सो V माइनस Ig इंटू जी इज इक्वल टू आर. सो 1 मिनट. V at A माइनस Ig इंटू जी माइनस Ig इंटू आर इज इक्वल V at B. सो V A माइनस B हाउ मच होगा? Ig इंटू जी प्लस आर. सो और एक यहाँ G रहे, Ig रहेगा. ओके, सो R वैल्यू विल बी V माइनस Ig divided by Ig. So what will you get? So V by Ig minus G. Okay, so R is equal to V by Ig minus G. This is the resistance which you have to connect in what? V by Ig minus G resistance, where we have to connect in series, okay, to a galvanometer, so that this galvanometer will convert into what? Voltmeter. This is resistance, and इसको हम ऐसा बोलते हैं. ठीक है. सो नाउ यू कैन सी हियर voltmeter and we are connecting in what? In parallel. So मान लीजिए a particular branch of a circuit is here. Okay, so you are connecting this voltmeter in parallel. So why parallel? Means in potential difference across whatever the drop because of some current, some current. So current through this one is, for example, some current through voltmeter is this one. Remaining current is I minus I voltmeter. See, by connecting this in parallel, you should not affect the circuit resistance, isn't it? Therefore, actually whatever the current is flowing, it has to flow same almost. That's why this particular voltmeter should not draw more current. Should not draw more current means whatever, its resistance is very large. That's why whatever the galvanometer is having now some 50 or 100 ohm. So that's why we're connecting large resistance in series. When you connect large resistance in series here, no, this branch resistance increases very large, so that current drawn will be very, very small. Okay, that's why ideal voltmeter resistance should be infinite. It should not draw any current. So whatever the current, it has to flow in the same circuit. And when you are connecting over here, it should not draw any current, but it should measure only the potential difference between these 2 points. Okay, that's the purpose why we are connecting large resistance in series to the galvanometer, so that it converts into what? It converts into voltmeter. You are getting? Yeah. So now, so that value of R just now we have found, that is equal to V by Ig minus G for range of voltage. Okay, we'll see one problem here also. See, resistance of just now we have seen, as you are connecting in series, no, resistance of now resultant voltmeter will be greater than the galvanometer resistance. Okay, to increase the range of voltmeter, series resistance must be what? That it has to increase. Why? See here, R is equal to V value how much? Just now we have seen V is equal to, I calculated here, potential difference is Ig into G plus R into. If we increase the value of R, no, then only this value of voltage value here increases. Okay, yeah. See this problem now. Galvanometer of resistance 50 ohm. Okay, gives full scale deflection for 2 milliampere current. What series resistance must be connected to convert it into voltmeter of range this much? So there is series resistance connected is equal to formula is what? R is equal to V by Ig minus G. So we have much volt 10 volts by 2 milliampere. So 2 into 10 power minus 3 minus this resistance is 50 ohm beta, है ना? So ये क्या हो जाएगा बोलो 5000 minus 50 क्या होगा 4950 ohm. This is what series resistance we have to connect, and resultant resistance will be these two. If you add, no, 4950 plus 50, that is 5000 ohms. Okay, and this is the resistance series which you have to connect for measuring a voltage range of how much? That is 10 volts. Clear? This is what galvanometer converting into voltmeter and galvanometer converting into a ammeter. So ammeter should be connected in series and voltmeter should be connected in parallel. Potential difference remain the same, and by connecting in parallel, potential difference remains same. And why galvanometer should have large resistance in voltmeter? It should not draw any circuit current. Okay, and in ammeter you are connecting in series, it will affect the circuit current. Circuit current को affect करेगा, लेकिन क्या होना है, उसका इफेक्ट बहुत कम होना चाहिए. इसलिए हम क्या कर रहे हैं, उसका रेजिस्टेंस को कम कर दे रहे हैं. कैसा कम कर रहे हैं? उसको पैरेलल में एक रेजिस्टेंस हम कनेक्ट कर रहे हैं. इसकी वजह से क्या होगा, रिजल्टेंट रेजिस्टेंस विल बी स्मॉलर देन इवन स्मॉल शंट रेजिस्टेंस. सो इट विल मेजर अप्रॉक्सिमेटली द सेम करंट इन द circuit. Okay, this is what the conversion of voltmeter into ammeter, galvanometer into voltmeter, and what galvanometer into ammeter. Okay, so see, I mentioned summary series में connect करना है, parallel में connect करना है, low resistance, यहाँ high resistance will decrease, resistance will increase. Ideal ammeter resistance is 0, ideal voltmeter resistance is infinity. Okay, so decrease the value of shunt for increasing what? Voltage range. Increase the value of resistance for increasing voltage range. Here current range, here voltage range. And key formula Ig into G by I minus Ig, here V by Ig minus G. Okay, this is what we have seen. Okay, so fine, please practice well and all the best. Okay, so please do subscribe and share my channel, and you can give comments, okay, in description box. Yeah, thank you all, good day.